participant list is slowed down and we're about 7 minutes in. So shall we go ahead and get started? Okay. Well, welcome everyone to a round of code and technical discussions today. Our agenda is still pretty light. And mostly I would love to hear from Nell, and I don't see David on the call. That's okay, but it'll be recorded. He can catch up later. Nell, do you want to take it away?
Sure. So myself, David, and Frederick have all been working on a Rust implementation of GitBOM. I'm going to go ahead and share my screen. Host is just, yep, you're on it. All right, cool. So let me go ahead and share my screen. So what I'm going to demo today, here on the left, I have the GitBOM RS library. And this is a library that has an implementation of GitBOM in it. I'll just take a quick browse through it. Mostly one file, implementing some data structures. One thing we did intentionally do was make it so that hash algorithms can be swapped out, can be added to. There's not a consensus yet on what hash algorithm will require for GitBOM or multiple. So we decided let's future-proof this and make this as hot swappable as possible. And then along with the library in a separate repo over here on the right, I've created a command line interface that uses this library to generate GitBOMs. And at the moment it's in separate repos. It just felt a little cleaner and I wanted to iterate much faster on the CLI one. They can potentially be combined, but they are different. In Rust, often the library is one crate and the implementation of it, the tool that uses it is another crate. You can have multiple crates in the same repo, so we might combine them, or we might just bring this command line repo over to the GitBOM organization, still to be determined. And with
my general advice is do what feels natural.
Yeah.
It sounds like the natural Rust proclivity matches my general personal proclivities and such matters as well, but again, whatever feels natural for the folks actually doing the work.
I'll jump in and comment. Having the CLI and sort of the thing it's talking to in separate repos often helps with compatibility testing across upgrade boundaries. So if it's natural to do it this way, I give it a +1.
Awesome. And the main reason I created a CLI, we do have the Go CLI, we have bomsh, et cetera. The best way to exercise a library is to have something that implements it. So whether or not the CLI goes into general use, we certainly can release it for general use if you want to. It's been enormously helpful in informing how we execute on the library. And so with that, I will go ahead and do a demo. Let me just check chat real quick. Okay, cool. Let me close that. Let's pull up my terminal here, and I'm going to up the text a little bit. Let's just make this full screen. And let me make sure I already got rid of any lingering bombs. I did. All right, so I have already compiled the GitBOM RS CLI. So I'm just going to call that binary. And there we go. And the first command I'm going to show is the bomb command. This is for generating a single GitBOM or single gitoid for one file. So let's go ahead and let's do that for, I have my main.rs file in my source directory. Let's do that. Generated the gitoid for it. If I look in my .bomb directory object, I will see that it is sharded by the first two. I know we're going to have some discussions in the future about what the best way to do that is, but that's the file. If we look at the file, we see we've got our blob and we've got our gitoid there. This is not exactly, in fact, I'll just open the file. That might be a little easier.
So the direct name should be objects, right? We should have the S, right?
Oh, you're absolutely right. That's an error on my part.
Yeah.
Fortunately, an easy fix.
Sure.
The other thing I noticed is it doesn't appear like the line is new line terminated.
Right. Yeah, and that would be a good thing to add as well.
Small things.
Also,
things,
fortunately, easy fix. So I'm going to show next. Let's go ahead and clear this. the artifact tree command. So let's put that in there. GitBOM CLI, that's the compiled executable artifact tree. And let's just use my test directory. In fact, let me show you our test directory. We've got some fixtures, we've got our integration tests, we've got some other directories, including one called directory thing, because I could not come up with a better term at that point. So let's go ahead and run it. Artifact tree test. And that generates gitoids for each of the files within these directories. And if I look now at my bomb/object, which will soon be objects, I can see I have generated files for each of these. If we look closer at one, let's just cat that. So I have one for each of these. I do not have a comprehensive GitBOM doc yet. That will be a next step. Also another, oh, David joined, yay. Also another next step, David added in some asynchronous API methods within the GitBOM RS library. GitBOM CLI does not use those yet. It will be adding those in.
I look forward to that, and it'll be fun to refine how we do the async APIs.
Yes.
Yash's comments were so illuminating for me. So I'd love to actually pressure test some of the APIs with real world stuff. And do we go back and add, here's a path to a file. Now do the async open and pass that in. Should that be in the library, or should that be in the consumer of the library? So doing fun stuff like that is just going to be awesome.
Yeah. But that's the basics of what we have right now. Very much still a prototype, but it's been a lot of fun to work on.
It's a great start. Now, could you show me a little bit of the interface for this, for how files are passed in? I want to imagine.
Oh, sure.
If I were not using the CLI tool, but I were using the library directly from, compiled it and then in something else, like a compiler, what would that call surface look like?
The best way to look at that would likely be looking at our tests in the library.
Okay.
So let me just go down to the bottom here. So what you do is you call in the library. We're using it in this case. You would import it into your crate or your Rust compiler, even whatever your Rust file is. You could create a new gitoid. You pass in the type of hash algorithm you want to create it with, and the input. That can be a string. It can also be a buffer that's reading a file. Here we are, new from reader. We also at the moment pass in the expected length into it, which has introduced a little bit of trickiness that we're still going to work through. But that is how you generate a gitoid.
And what is the add many function that I see on the screen in a few spots?
Add many.
Scroll up a little bit right there.
Yeah, that is creating a new GitBOM document and adding in a bunch of gitoids at the same time.
Okay. So you can create a gitoid for a specific string or buffer, and you can nest that by, once you've made those, create the GitBOM document by adding many oids that you've already calculated. Right.
And the way I'm doing it in the, when I use the artifact tree commands, let me pull this up. At the moment, I'm walking the directory that I pass, going through it, skipping any that are any entries within that directory that are directories. That's a decision we can revisit if needed, and then creating gitoids for each of the files, and it will add them to a GitBOM as well.
From a compiler or linker perspective, what I'm imagining, instead of this linear walk across a directory, is you create a data structure that gets called into repeatedly each time that the compiler touches a new file. You say calculate the OID and add it to that object. Just add a couple lines, or like a decorator in Python terms.
What will also be interesting is Rust uses a lot of syntactic sugar. So when the Rust compiler compiles a file, it expands macros, it expands, the sugar into, more verbose Rust code. And the question then becomes, do we make the gitoid based on the original code, which is what I lean to, or do we make it based on the, and there's several layers of it being lowered into different representations of it, which will be something we'll need to discuss more.
That's going to be a very interesting discussion that comes up in a lot of other communities as well.
Yeah, when do we want to get into that?
Pretty soon, probably in the spec half of the meetings rather than the code half. But yeah, I think we need to tackle that soon. I want to make sure that we have some of the folks who are on this call and some folks who are not on the call today, including folks from, say, the Windows side of the world and a couple other languages, because the differences there, sort of where you draw the line, as Nell put it, like how deep in the expansion you're drawing that line is going to really impact.
Well, it also sort of like what the particular behaviors within the toolchain communities are like. So for example, I can always use a -E to force the expansion of a .c file with all the appropriate imports. So basically the post pre-processing step. But most modern compilers don't even do that step, right? Unless you force them to. Most modern compilers sort of do something in line and there's not really an intermediate step there. And so forcing them to do that intermediate step would slow a lot of compilers down. It would screw with precompiled headers. And that's gonna, but I'm thinking about C here. I have no idea what Rust is doing.
Rust has like 3 or 4 layers of intermediate representation that it goes through until it gets to the machine code.
Well, and the other question really is, how stable are those intermediate layers, right? Often, I guess the point I'm making on the C side is, the preprocessor expansion has evolved as a matter of practice to no longer be part of the contract in C,
right?
Because so many other things are happening.
Oh, so I guess we're having the conversation now.
David's got his hand up.
Yeah, and I can't figure out, I'm on a different version of Zoom and I can't figure out how to actually put my hand up. So thank you for recognizing my video hand. I think that it would be valuable, no matter what else we do, to be able to have an actual equal gitoid hash of a gitbom file, and what is stored in the Git repository. So we're doing a lot of stuff to make sure that we have absolute equivalence with hashing. So we should be able to say here at some point in the representation, you have an equivalent, you have a hash that you can also look at Git and say, give me the thing that hash represents. Because a lot of what we're going to want to do here over time is kind of cross-check. We're going to want to be able to say, okay, somebody made an assertion. Can we validate that assertion is true? Because okay, I'll shut up now.
So
go ahead.
I'm just building on what you're saying. I don't mean to cut you off.
I thought you were putting up your hand or saying enough.
No. I'm just doing
that's this, which I'm not doing.
Or clarifying question, timeout. You're next, which is hard to do without actually being in the same room.
All right. Well, y'all get my point. And so as long as we can have those auditabilities and cross checks, whatever else we do is icing on the cake.
So I think what we need to reflect better, perhaps in the docs, is that a tree can have a single precursor node, right? These steps to expand a macro are a valid transformation that take an object from one state to another state. We need to reflect both of those gitoids, the one that's on disk and the post-mutation one that's still just a linear dependency. You have a compiler or macro utility, and you have the input file. You've done an expansion, right? Those are still 2 reference points. One file, one operator, one output.
Yeah, and so source code or object code, compiled object code is just another step in that chain. And then linked code is another step in that chain. So yeah, there might be intermediate steps, and this goes into some really interesting stuff with TypeScript versus JavaScript. Also, there's a bunch of interesting stuff that could be done around that with Scala, because Scala does go through a series of transformation phases.
I think Elliot has his hand up.
Yeah, and I always have to remember to put my hand down because I'm not good at that. So Ava and David, I think you guys just said it so perfectly. This is one of those moments where it's really good that you're recording the meetings because you captured the principle really well. And to Ed's point about how the compiler is optimized, you know, Ed, I think what's going to happen with compilers like Clang and such is even at a certain point, they leave artifacts that things have been included, and they just need to mark those artifacts to do the job that they need to do. But the overarching point is we just need to make it the compiler's problem and let the Clang people figure it out, or the GCC people figure it out, or the Go people figure it out, however you want to go, so to speak. Same with Rust. Which reminds me, we were talking about Rust.
Yeah.
Indeed.
Ferris will give his approval.
So to Elliot's point, I think I agree. Capturing these ideas in a way that can be extrapolated, not just to Rust or Go, but to other languages and tool chains. That's the purpose of the spec work. We've got to just do that writing at this point. Like I think this is surfacing up a really good learning, which is why we have the back and forth.
I think out of the build tool information, right, we can capture them as the metadata, right, pass along with the GitBOM tree, right? So for example, bomsh, when we do the GitBOM tree generation, we actually already carry on some, for example, build tool information, the hash, that kind of thing, and other metadata. For example, in the CVE information, we can carry on together as a metadata attached to the GitBOM tree. Yeah, that's just not 2 cents.
No, that's also true. But I think what Dave's saying was the fundamental one, which is as long as the transformation tool preserves the original input, right? Whatever it chooses to do for intermediate steps is its problem, and there will be a bit of figuring out what different languages and what to do there.
Yeah, that's right.
Capturing the version of the compiler that's used, I think it's already been said, but would be very helpful as well. I mean, with Rust, at least, they're not going to change macro expansion and release something under the same version number.
Yeah, I have some things that I've actually attached to the spec. I think talking about that, is that actually true? Oh, they're attached as issues. Looking at representation of build tool and build configuration, which we can look at next week when we're actually in the spec call. And I'm not super attached to these. It's just one approach to the problem if folks are interested. Because you're absolutely right. Like everyone asks about it, which probably means it's a real thing.
I tried to capture some of the points, folks. I see your hand. One quick second. I tried to capture some of the points in the notes doc. I'm going to make sure that I got that right. Ed, your point was that as long as the tool preserves the original content in a deterministic way, then we would not need to capture the intermediary representation so long as we have the original input and the tool version itself.
I guess the point I was making is the hard and fast rule is that if you're a build tool, you need to capture in the tree the actual inputs you took in and the actual outputs that you put out. Intermediate representations of various sorts, that's the whole optional thing you can work out for yourself. But if you didn't capture what actually came in and what actually went out, then there's a problem.
Gotcha. Thank you. Elliot.
Thank you. Boy, now 2 comments. First of all, Ed, you just said a mouthful there, because I think that goes back to the earlier discussion, Jeremy, right? That you were having concerns about with different hashes and the impact that could have in at least in part in intermediate formats. At least that's what I recall. So I think that's one aspect. I had sort of a rather light comment to make, though. So you're talking about versions of compilers. I think probably it would be an interesting thing to get to the point where the version itself is described by the git bomb, right, and the git hash, so that, you know, we're not looking at numbers. It's in a way, it's sort of like eating your own dog food, right? That's the phrase we use at Cisco from time to time, is eating our own dog food.
I've also heard it as I've also heard it as drinking your own champagne, but either works.
Oh, that's a much nicer way to put it, isn't it? We're people of negativity at Cisco, so it works well for us to think about dog food.
Speak for yourself.
You're so wrong about that. Sorry, just couldn't resist.
Elliot, is your point that just capturing the version string is enough as opposed to capturing more, or okay? What
I'm saying is, when we say the version string, and it's come up a couple of times in the compiler discussion.
Yeah.
And this is not like, it's not something we should beat ourselves over, but it would be cool. It would be absolutely, it's the same way, like you go back to the earlier days of GCC, you know it was going to succeed when the compiler could compile the compiler, right? And so if the compiler itself is using GitBOM technology to describe its versioning, then you know you're well on your way, right? And it's almost like it's almost like table stakes to know that you're on your way. So I just wanted to note that as an aside. It's not something that you have to dwell on here, but I thought it would be an interesting thing for people to think about. And in particular, Nell, as you're getting, as you're doing this work with Rust, I don't know if you're talking to the Rust compiler people, but
I know them well.
Okay, because I don't know anybody well.
And I've contributed to the Rust compiler as well.
Okay, so then you know them really well.
Yeah, I used to work with two of them at Mozilla.
Okay, very good. So yeah, that you might pass along this idea, you know, wouldn't it be cool if, and
we're in discussions.
Okay, so just call me Captain Obvious. I'll be quiet now.
It's okay. I hadn't said that anywhere. So it's all good. I appreciate you making me clarify that.
Please admit that Elliot mentioned he is now Captain Obvious.
I will take that. I'll capture that in the meeting notes. And I guess to make it clear to anyone as far as assumptions are going, we are also chatting with the .NET compiler folks inside Microsoft, though they aren't making it to this meeting, timing, etc. We are chatting with them regularly, if not every week. Jeremy, I see your hand up.
So I apologize. I missed the first 20 minutes or so of the conversation. So if I'm repeating anything, just tell me and I'll go.
Nell gave a wonderful demo.
Excellent. This question about whether or not the BOM should include the toolchain information, I find interesting. And I think one of the interesting things I found about the GitBOM design was that it does not include toolchain information, because in a sense, the toolchain is not relevant so long as if you have a given tool that produces the same output from the same input, exactly what the bits are making up that tool is not important. And you can imagine that if you're building on an x86 system or you're building on an ARM system, cross-building on an ARM system, the fact that the compiler is running x86 or ARM instructions is irrelevant so long as it produces the same output. So including the compiler information as part of the BOM might be helpful for someone who wants to be able to reproduce the build and say, what compiler do I use to get these particular bits as the output? But incorporating those compiler versioning bits into the output itself just makes it difficult.
So we've had several discussions about what is directly in the BOM and what is sort of additionally helpful context to be stored adjacent to the BOM that can optionally be propagated between build steps. Do you have that background, Jeremy?
So I guess the context I missed in this conversation was exactly about whether, when we're talking about compiler version information, whether that's, going into the BOM or if it's adjacent. And if you're having adjacent metadata in the BOM, then that kind of opens the door for all sorts of other kinds of metadata in the BOM. So
yeah, I mean, so what I would wholeheartedly agree with you on, I think we're in complete alignment on, is that one has to be very cautious or you end up doing it wrong, right? If you're going to have it, when you're dealing with bringing the build tool information in. There are, however, certain kinds of vulnerabilities that actually do exist by virtue of the build tool itself. I've seen a number of compiler bugs in my career where they actually introduce insecurities or sometimes fix insecurities at the level of the compiler that's being used. And so inevitably, almost every time I talk to sort of a deep vulnerability chaser, somebody who sort of has been doing this for a long, long time, they will inevitably bring up the existence of bugs like that. Now, whether we want to cover those or not, and how we want to cover those or not, and how we do this so we're not quote unquote doing it wrong, those are interesting and involve questions probably for the spec meeting. I do have sort of like in the issue I dropped in the meeting minutes, there are a few sort of preliminary thoughts. They should be taken with the level of seriousness of all my preliminary thoughts, which means there's about a 50% chance they're stupid. But it is an interesting area to be discussing so we can try and figure out what the right approach is.
I mean, the other thing, of course, is that we can't trust any of these tools in themselves, like what output they produce. Like they can claim anything they want in their BOM, and if you don't, so it doesn't really matter what the compiler self-declares itself to be. It doesn't give you any extra information from a security perspective.
So I think we got Dave as well.
So I'm actually in the include as much optional data as possible in BOM metadata so that we can track this. We can track compiler versions, and quite frankly, cross-compiling there may be bugs when you cross-compile that are not seen in a native compiler. In other words, if you're cross-compiling from x86 to ARM, you might actually see bugs that if you used exactly the same version of the compiler on ARM, you wouldn't see. So I'd rather capture as much of that information as possible. The other thing is, I think there are ways that we can start making, and this gets back to my auditing comment earlier, if the tool says I use compiler X, you can actually check that. And there might be, whether it's metadata from the compiler that's inserted into a .o file or from a linker or whatever, we should start being able to say, yes, we can validate whether or not something is true, or we can at least have, I shouldn't say validate true or false, but we can give a spectrum of trust for assertions that different tools and different BOM generation systems create. So I think having more information allows the exploration of more of these, how trustworthy are the assertions.
I'm going to put an end to this conversation here, as this really, I think, should move over to the spec track. And I want to add a food for thought, perhaps tracking certain types of build metadata should be done not in a completely orthogonal way, somehow in the tree, but not in the same part of the tree, perhaps a different file type or a prefix type, BOM, meta. I don't know. Food for thought for how we track this. I think it's clear that there are cases where it is really important that people have been surfacing up that we do need to track this data. Let's pick that back up in the spec call next week. And I would love to turn the floor over. We have two more agenda items. Bharati introduced one for an update on the kernel build. Want to hear about that. And then gitbom-go. I think that was Frederick. I'm putting your name on it if it wasn't you anyway. So Bharati, the floor is yours.
Okay, so I just wanted to update that I tried building the kernel with the clang compiler with the gitbom enabled for clang and LLD, and the build was successful. I got all the gitbom files generated for the final VM Linux binary, and several close to about 3,000 GitBOM files for the objects. So right now, I don't have a way to verify that it's all correct. I wanted to just cross-check it with Yongkyu's the bomsh also, and his compare notes to see that exercise is pending. But I just wanted to update that the build was successful, and I have all the expected piece of information that is generated. And I think it was close to about the size of the GitBOM directory itself is about 32K for the entire Linux build, which is, I think, good.
That's fantastic. One thing that we may want to think about, particularly now we've got folks working on the Rust and the Golang libraries, is it would be really helpful to have a tool that could be used to try and do sort of a sanity level validation of things like the llvm build that you had, where you could sort of point it at a directory and it would say, okay, well, I find .bomb sections in all the .o files. That's a pretty good sign. I find the actual git bombs related to all those embedded git bomb identifiers in roughly the place I expect to find them, and they contain things that look like git bombs.
So the flip side of the Rust library that is generating these would be a library to read them and do comparative analysis and say, does this bomb file look like it's got all the right blobs for those files? And then a set of CLIs to interact with that. How far away do you think we are from something like that? Either in Go or Rust?
Yeah, also, I think Yongkyu has a tool to generate the GitBOM JSON file or something with all the data, right? That can be used. It's because it's independent of what process you use to build, as long as those files are generated, that script can be run, and we can have that'll be like one common point of data for comparison.
Yep. No, I mean, having the ability to cross compare and actually see that we agree is a really good confidence builder.
Yeah, we need to have some criteria to say, okay, this is good. The information generated makes sense, etc.
And forcing us to, oh, sorry, Bharathi, go ahead.
Yeah, the same thing. I think whatever you were planning to say, I meant to convey the same.
Yep, forcing us to capture those criteria in code also forces us to have the discussions on them. I could implement that in Rust. Rust might be a bit overkill for you. It might be easier to use a scripting, more traditional scripting language, but anything will work in this case. It just needs to be easy to run.
The one thing that Rust really has going for it, because I sort of browsed around looking for language libraries, is there is an object crate in Rust.
Yes.
That understands a huge swath of things. It understands ELF files, it understands PE files, it understands.
That's a good point.
Whatever, I don't remember what macOS is calling its files. It was sort of like, it was clearly head and shoulders the best version of a library for this sort of purpose that I saw. Now, if you're just going to go through ELF files, Go is not that different in complexity from a scripting language at this point. It's nice that way. And they do have a good ELF reader library. Not so great for writing, but reading, fantastic.
But we're going to want to Ed's point, be able to read BOM headers from dozens of different file types over time. Mm-hmm. And one CLI or library that can interact with all those different file types, well, it could be written in any language. It'll be nice to have it written in one.
Understood.
Yeah, and normal rules apply. People should do things that sound like fun and that interest them.
Of course.
Yeah, but this one, if I could jump in for a second, I think this one is one where whatever we write that library in, that's going to form the basis of a lot of the way that folks consume the project. Mm-hmm.
Yeah.
So my initial bias is towards Rust, and anytime somebody says Rust, I was putting my arm behind my back saying, Ed, twist my arm. But thinking about it a little bit more, Python strikes me as possibly the most accessible system for the consumers of what we're going to be building. I mean, Go is a close second, but Rust, there is a barrier to Rust for anybody who's going to be contributing.
Hmm.
And so I think that's something that we should at least consider. I agree with the, do what you love, but this is one that I think is going to have long-ranging implications.
So I think basically, I think you've got two sets of consumers to worry about. One is people who are going to contribute to expanding out the library. And the other is people who are actually going to grab and use the thing. And the single binariness of both Rust and Go and the tool chains they have around it and the simplicity when publishing Docker containers for it, on both of those languages is very, 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 very compelling from a consumption side. Now, from contribution side, the learning curve on Rust is a little greater than the learning curve on Go. I think that's generally acknowledged. Rust has other cool things going for it. But at the end of the day, my big concern is I would rather have multiple people poking at problems and finding interesting solutions to them than have some folks wander away and say, okay, we've decided we're not going to do it in the way that I am comfortable working. I don't want that to happen.
Well, I mean, just speaking for me, I don't care. I mean, I'm biased towards Rust. I don't care what language. I'm going to, contribute as much as I can. But your point about single binary is a really, really compelling one, which is if you can do an SCP of a single binary someplace.
Yep.
That's really nice.
Yep. And Python is useful for that. Python is a very easy one for prototyping, but for, I don't know, I'd have to dive back in to see if it has a lot of the utilities we'd need already, or if we would end up having to write Python interfaces to read this out of stuff. It's not been my experience that it's rich in those.
I think Frederick has his hand up.
Yep, I do want to track time,
sorry.
and I think Frederick, you're next, whether with a question or switching over to gitbom go.
Cool. Yeah, it was more of start with a comment from previous as well. So I do think that we should look at this from different actors' perspective. So if you're a compiler designer or you're building a tool, then very likely those tools for generating git bombs you're going to want them centered around whatever the language is built in. And I specifically say built in because you might have a language that is actually built in another language. But generally, if it's like the Go community, very likely you'll want to have something that's written in Go. If it's in Rust, you probably want to have something that's written in Rust. But for the actual consuming, like when you start looking at the various InfoSec teams that are out there or security teams that are out there, they're very much aligned with Python. So we'll very likely need to have something, even if we don't necessarily produce things through the Python approach, because if I recall, Python is written in C. But even if we don't have that particular thing there, we still need to have something that makes it trivial for somebody to be able to consume it and to be able to build workloads or workflows that surround the consumption of GitBOM. So I do think that every language it will need to have something in that relation. But I would strongly recommend splitting it up into those at minimum those two types of actors and to treat them as very different. Switching over to the GitBOM Go part, that is just a very simple thing. So there were two things that were done there. So the first one is, GitBOM Go now lives in the GitBOM organization. So you can go see that. I remerged now that 118 is released. I've now merged the CLI and the library back into the same repository, so they'll both track together. The second thing that I've done as an experiment, as I experimented with combining the SHA-1 and SHA-256 into a single line. And so right now the format looks a little bit different than it did before. I'm going to add a little bit more tooling into there so we can, through some environment variable or something similar, we can specify what kind of line output we want. And the reason for that specifically is to assist with, as the spec evolves, we may end up with different versions as we track over time. So it provides a way for us to experiment or track along with what with different GitBOM formats until we settle. And then once we settle on something, then my strong recommendation would be to remove all of that extra scaffolding and then just focus explicitly on the one true format that comes out. But in short, that's some of the work that's gone on with that.
Sounds good. No comments from me. Anybody else have thoughts or comments on GitBOM-go? Going once? Glad somebody got my joke.
You had to go do that.
I did. Yonghui, a quick update on bomsh. Keep it about 5 minutes, and then we'll have a few minutes to wrap up.
Sure, let me share. So I want to do just a quick update on this. So still, I have committed some new code to the bomsh for the CV database creation. So we use the OpenSL as an example. So we use the CV add commits and CV fix commits. So now I added a little more for the CV checking rules. So you can see for each CV, I can have this kind of definition, include some string in the source code file or exclude something, so that I can check directly on each individual source file, whether it contains this CVE or whether it has fixed this CVE. So with this YAML format, we can use that in at least 2 ways. So first is that we can, for each Linux distro, for those kind of, this is not official Git repo. If it's official Git repo, our CV add commits and CV fix commits should cover all the blobs in the Git repo. But in the each Linux distro, for example, RPM or Debian, they may have some backporting of the CV fix, and that will create some additional blob ID that's not covered in the official Git repo. So in that
Sorry,
case,
Yonghui, sorry to interrupt you, but I think I'm missing a bunch of the context here.
oh, this is for the CV database. So basically for the, so right, for the, after we have the GitBOM tree, it lays the foundation for any additional functionality, for example, CV vulnerability search for your bandwidth, right?
So you have a separate tool for building the CVE databases.
Yes. So in bomsh, it's a collection tool, not just the tool to build GitBOM tree. It includes how you create a CV database, how to search the CV database using the GitBOM tree. So that's a lot of tools over there, not just a single tool. Okay.
Gotcha.
Yeah. So this is for that part, not the GitBOM part. It's, I mean, eventually this will yield the GitBOM tree. So this will, the goal is to create a database that mapping blob IDs to the CV vulnerability. So this take care of that. So this will cover all the blob IDs that's available for all the major Linux distro. The other is that we can do it directly during the GitBOM tree generation. So we will record the additional metadata, that's a CVE checking result for each individual source file. So we'll carry on with this additional metadata, save in the metadata directory. So later our bomsh search CVE script will be able to utilize these additional metadata to report CVE vulnerability. So basically 2 approach for that. So with this, I think it's more complete for the CV database. So with the OpenSL as example, I have successfully, I mean, I think it's very successful in discovering the CV vulnerability for all the major Linux, I mean, the release version, that kind of thing. Yeah, basically that. I created some.
So I still, maybe I need to go dive into the repo itself and understand how this is working, but I'm not conceptualizing how this connects to GitBOM documents in general, or to what other folks are doing on the call. How would this work with gitbom-go or gitbom-rs?
Yeah, you can see in the bomsh, right, we have script to create a CVE database. And then later we have the search CVE. Basically, if you read all the documentation here, right, you can search, for example, for the Rust package, for the Go language package, right? You generate the gitbom tree, you create the CV database, then you just search for any binary you built, right? It will, for example, you can see this is a Conquer Rust package. Give the git hash of this binary.
So I think part of what's going on with the CVE database is right now we don't have indexing of CVEs by the blobs of source code files. But what Youngkui has actually built as a tool that will allow you to construct a not entirely perfect, but really freaking useful CVE database indexing CVEs back to blobs that are probably the source of those CVEs, so that you can actually close the loop on the question of, okay, so I have this gitbom tree. What actually does it tell me about the vulnerabilities that I may have in my my executable? And that's sort of an interesting area to look at, because I do get questions around like, but I've had a number of people say, but we don't currently index CVEs back to blobs, and that's a totally valid concern.
Yep.
But this tool
what I'm lacking though is how. So, on the one hand, how is this tool generating the database, or have you built it by hand? Like what you're showing right now looks like it's kind of built by hand. The flip side then is, how does it?
Not by hand. This tool will generate the database. So, yeah. So
Can I just point it at any project in the world and it will build a database for me?
It will, and we need more volunteers, right, for this. But basically, we have laid the infrastructure to do that.
Yeah, so I think the really interesting question here, and this is, I think, what Ava may be getting to is, what are the inputs to the tool, right?
There are two questions I want to pull apart here, and Ed, you're close. One is, what are the inputs to the tool? And the other is, how does it intersect with gitbom file format discussions or the gitbom build process build tool discussions we've been having? Should this be a separate work stream? Which, I mean, this does answer one of the big questions we've all been looking at, like, how do we correlate this? But it sounds like it's a significant enough separate thing. It doesn't intersect with Git file format discussion from the specs thread and some of the stuff we pulled up today. And it starts to step more into the open source ecosystem. How does this search or cross-reference CVE databases with open source repository and Git history? And then, so that's a set of output. It sounds like output from this tool. Then we have the work to build gitbom documents and then correlate those two. Is that, am I getting a good conceptual map here?
Yes, exactly. Yeah,
okay.
That's right. In the bomsh framework, we have those 3 blocks, right? That's basically what we,
So Ed, what do you think about having a parallel work stream? Now that we have, sorry, David, I see your hand up. Go for it.
So I think that this does impact the BOM file format, because this is a consumer along the pipeline. I actually wouldn't see this as a direct consumer. I would see this as an indirect consumer over time. But being able to make sure that whatever we put in the file format, whatever we do with metadata, can service an application like this is super important, because this actually goes to the heart of why a software bill of materials should exist. And you say, okay, am I vulnerable? Am I not? And this is a really powerful way of saying that.
Yeah. And Frederick, I'm glad you're here on the call, because this is the kind of thing that I want you to, your perspective on. In the Kubernetes and cloud native worlds, being able to take a list of CVEs and a list of gitboms or gitbom documents and connect them at runtime in a Kubernetes admission controller. like as a consumer of the GitBOM work we're doing and the kind of database that Yong Kwai is describing here, to cross-reference those in an admission controller or in a scan of a container image registry or packet registry.
Yeah, there's a couple things here that I'm interested in, and this is definitely leading towards that. The first one is I do want to get visibility on what vulnerabilities are present within the system. And there's various ways to do that. One of the problems that I run into is that many vendors will backport their, like I might have a specific version of a library, and the vendor will backport some of the bug fixes, but the application will still come across as being vulnerable even though it's been patched. So it causes noise in the system and reduces trust in the abilities of the system. So being able to correlate that there's a vulnerability is a super important step, but we need to also take it a step further. My end goal with the environments that I run are specifically to eventually take this information and then to send it back to the vendors and say, hey, I have this thing that popped up. Can you give me a vex statement on whether I'm actually affected by this? And then we can use that to try to narrow down where we can spend our attention. And we know that there's going to be gaps. We know that there's going to be a little bit of, like, somebody might get something wrong, but the total area that allows us to focus our attention and allows us to spend our money more wisely towards fixing problems is going to be hugely helpful, because at the end of the day, it comes down to the economics. So I see GitBOM, like the ability to track the CVEs. These things will very likely be most useful in the initial build when I do a build to ensure that the teams, as they're building their software with CI/CD, we get that visibility out. If somebody copies and pastes a file, then ideally, best case scenario, the environment will actually give the developer up to date information that, hey, you're actually possibly importing a CVE. You need to ensure that you're not going to be affected by it, and to be able to store that metadata somewhere. I don't think it should be the GitBOM itself that is modified to store that data, but we need to be able to reference from the GitBOM to the CVEs and vice versa. So I think that the correlation is important, but I don't know the right way to do that correlation just yet, other than I don't think that the correlation should be explicitly done in GitBOM itself, would be my recommendation.
Don't think it should be in the GitBOM at all, because it's not static. A GitBOM is a static reflection of a set of facts at build time.
Exactly. They are all metadata. Everything in the bomsh is metadata. CV information, build information, everything is metadata. So we attach those metadata to the GitBOM node.
I'm going to jump in and call time. Elliot, I see your hand up. Do you have closing comments?
Yeah, two quick points. The first is that to your earlier question, Ava, I think there is a little bit of a stream to kick off in terms of how GitBOMs are integrated into the other formats like Cyclone DX and CSAF. I don't think we're ready for it yet, but we will be soon. And we should probably at least open some issues in their trackers so that they know that it's coming. And that's one thing that would be useful. And then to Fred's comment, there's an inverse issue, and I just created issue 11 in our tracker on the spec, which is we all know that hashes are by design fragile, and so not only do you get a problem when there's a backport of a fix, as you describe, but more often than in my life, and in some of my environments, people absolutely backport their changes into code that is broken. So in both of those cases, you can lose the hash. And so one of the questions we should be thinking about is, what hashes do you want to look at when you're doing the analysis, and what needs to be available the context of trying to construct whether or not a vulnerability really is present. So I know that's a big topic, and it's hopefully a juicy topic that we can discuss in greater detail over time.
Great point, Elliot. Thank you. Try to capture that in the notes. As ever, thank you all so much. It was a bunch of great discussions. Looking forward to next week where we can focus more on some specs. Happy Tuesday.
Thank you,
See you next
Ava,
time.
for chairing and all this.
Thanks.
Thanks.
Bye.